Hi guys, so welcome back to another video. The topic for today is statistics. This is one of the easiest topics in our exam. Okay, most of the questions are theoretical. Okay, a lot of us get confused in solving or understanding. If you understand this topic clearly, you can solve most of the questions within 1.5 minutes. Okay, so without further ado, let's get into the theory of this. Now, see, when we talk about statistics, okay, it's about collection, analysis, okay, collection, analysis and representation of data. Okay, nowadays, so when you think about statistics, you think about, good salary, right? Great packages, great jobs, right? So with respect to our syllabus, representation of the data is what we are looking for, okay, or is what we have to understand. So now when we talk about representation of data, let's take a generic example. Say you start preparing for your exam. So before you prepare for your exam or before you start your preparation, you keep a target score in your mind. Say for example, somebody might say that, sir, I am looking for a 705, plus minus 10 or plus minus 20 marks are enough, right? So, or you can say that, sir, I am looking for a 334, right? Plus minus 4 is enough for me, right? Or somebody can be even more specific and say, sir, I am looking for a 99.5 percentile, okay, not percentile, or a plus minus 0.2 is okay, right? So depending on what exam you are writing, right, we all have a target score in mind. Okay, we are okay to have a plus minus within that, right? So with respect to our data, see, this is called central value. Okay, this is called central value, the main value that we are looking at. Okay, a little bit of plus minus from there is allowed. Okay, so then talking about the various types of central values, right? Talking about the various types of central values that are there. With respect to our exam, there are three, which is mean, median and mode. Okay, these are mean, median and mode. Okay, the three M's. Right? Now we learn all of these one by one. Okay, what is mean? Right, it is also called average. Okay, it is also called average. Right, median is the middle value, right? Median is the middle value of the data, and mode is the most recurring, right? The value that repeats the most, right? The one that has highest frequency, right? Now you might think, right, the question does come to our mind that why don't we just use average for everything, right? Whatever we want to represent, whatever data we have, and if we want to represent, why don't we just use average for everything? Why do we need median or mode? So all the three, okay, all the three have their use cases. Okay, I'll just give you one example and then we quickly move to studying these. Say uh, this is some stone, some gemstone or something that we have. Okay, this is the size of that. Now if we want to figure out, okay, what will you say is the average width of it? Okay, so we'll all get vernier caliper. Do you remember we used to use vernier caliper in our school days? We get that vernier caliper and start measuring the width at various points. Say here we get 3 centimeter, 3 centimeter, 3.1, 3.5, right? Say, right, 3 again, 3 again. Say we have here also 3 again, 3 again, 3.8. Right? So on an average, now what happens if I ask, okay, what will you say is the width of this? Right? So instead of taking average, we'll see that, see, 3 is repeating the most number of times. Okay, the value 3 is repeating the most number of times. Only in couple of places it is deviating a bit. That could be because of human error or that could be because of mechanical error, right? So in such cases, instead of using the average, we use mode to represent that. See, out of 10, 12 values, 10 values are 3, only 2 values are different. Okay, so what can we say? That okay, we can use 3 centimeter as a good value to represent the width of this. Okay, so similarly, there are use cases for mode, mean, median, okay, all three of them. Okay, alright, so let's get into these one by one. So first is obviously mean, right? Mean is average, right? How do we find average? Which is simply total sum by total number, right? Sum of all the values by total number of the values, right? If we have say random 5-6 values given to us, okay, in a data set, that see the values of the data set are 2, 3, 5, 8, 9, okay, and they ask what is the mean of this. So all you do is you add these values, divide by 5, that's 27 by 5, 5.4, right? So we simply add all the values, divide by total number, right? Another way to solve for mean, okay, another way to solve for mean that depends on a different data set, right, is the concept of weighted average, right? Okay, what is that? So if we have data, okay, we have our x values and the frequency for the same, that okay, say there are 10 students in a class, okay, so the 10 will go to frequency. Say their average age is 23, there are 15 students in another class, say their average age is 20, okay, and we have to find the overall average of the whole class, right? So this is the concept of weighted average, right? So what do we do? So the weighted average is simply summation xi fi upon summation fi, which in another words is simply again total sum by total number. Okay, we haven't changed the concept, it's just the calculation of sum has changed. Okay, also I have covered mean, which is average, in another video, the one we did before this. So if you want, you can watch that in complete detail. There we have covered various types of averages and how to find averages in various different cases or scenarios, right? So here again XIFI, so we will do 10 into 23 plus 15 into 20 over 10 plus 15, 530 by 25, okay, 21.2, right? You can also use the weighted average formula that we have learned before, that is N1A1 plus minus N2A2 whole divided by N1 plus minus N2. This gives you the final average, right? This is your weighted average formula, okay? Or if you're using the same in statistics and you have a data given, right, a data table given, then the average becomes summation xi fi over summation fi, okay? All right, so from average or calculation of average, now we move to the calculation of median, okay? From average we move to calculation of median, right? Now median, as we said, median is the middlemost term, okay, of the data set, okay? So for that, one thing is super important, okay, you have to compulsorily arrange the data set, okay? We have to compulsorily arrange the data set, okay? You can't just say that okay, whatever the data is given, right? Say for example, let's take some values 1 2 3 5 8 8, okay, right? So say these are 11 values, okay, say these are 11 values, okay? So if there are 11 values, the median will be the sixth value. You can see 1 2 3 4 5 6, this is the median because this divides the data into two equal parts. You have 5 values here, you have 5 values here, this is exactly in the middle, right? So this becomes my median, okay? So if you have odd number of terms, okay, if you have odd number of terms, then the median is n plus 1 by 2th term, okay? The median is n plus 1 by 2th term, okay? Now as I said, it's important that you arrange the data. Say the same data, okay, say same data is given to me as 1 1 2 8, 5, 3, 8, 8, 11, 10, 9. Okay, the same values are now given to us in this order. Okay, pardon me for my bad handwriting. Okay, so say this is the data. Now if I'm looking for my median, so don't say okay 1, 2, 3, 4, 5. This is the sixth term, so this is the median. Okay, that is wrong. Okay, you need to arrange the data first. Alright, you can arrange it in ascending order or descending order, that does not matter, but you need to arrange the data first. Okay, only when you have arranged the data, then you look for the middlemost term. So we understood that if there are odd number of terms, median is one of the middle terms, right? It is one middle term. So it's a term from the data itself. But what if there are even terms? Okay, even terms means even number of terms, not that all values are even, but even number of terms. Say 1, 1, 2, 3, 5, 8, 8, 9. Okay, say we have 8 terms. Okay, or let's take 2 more, 10, 10 terms. Okay, say we have 10 terms in total. So now what will be the median? So we can't do 10 plus 1 by 2, right? If I do the same formula, 10 plus 1 by 2, I get 5.5th term. 5.5 decimal term is not possible. So instead what we do is we look at the average, because my median has to lie here in between, right? 5 terms here, 5 terms there. So the median needs to lie in between. Okay, so we take the average of middle two terms. So average of 5 plus 8 is 6.5. Okay, so if there are even number of terms, median is average of middle two terms. Okay, or n by 2th term plus n by 2 plus 1th term by 2, right? So if there are 10 terms, 10 by 2, 5th term, this is the 5th term, then 5 plus 1, 6th term, average of the 2. Okay, so when we talk about median, remember median is the middle term, and it is compulsory that for a median you either arrange the data in ascending order or descending order. Okay, moving on to the next point, that is mode. Mode is simple, it's the easiest of all. It's simply the one that occurs the most. So the value which has highest frequency. Okay, the value which has highest frequency. Okay, so for example, the data we took 1, 1, 2, 3, 5, 8, 8, 8, 9, 10, 11. Okay, in this data set, if you see, the mode is 8. Now, for any data point to be called a mode, the frequency has to be more than 1. Okay, the frequency has to be more than 1. For example, if I have 1, 2, 3, 4, 5, then we say there is no mode here. Okay, because all the values are just coming once. However, say if I have one more 1 and I have one more 5, then I will say the mode of this data set are 1 and 5 both. Okay, so data can have two modes. Okay, a data set can have two modes, that's not a problem. Okay, so these three, right, again these three combined are your central values. Okay, the main value that you are looking for from the data point or the data set. Alright, now we focus on the plus minus, sort of the error that we call, right, or you can also call it like a leeway or a room that you leave for yourself. Okay, so we have, right, range and standard deviation. Okay, so right, the leeway that we leave, okay, or the leeway that we have, right, that is called dispersion. Okay, the leeway that we have, the plus minus, right? The plus minus 10 that is allowed, or the plus minus 20 that is allowed, or the plus minus 0.5 percentile is allowed, right? Whatever the plus minus is, that's called dispersion. Now there are, with respect to our exam, right, two ways. We also have interquartile range, but we'll study that later. Okay, we also have interquartile range, but we study that later. Okay, so right now we just focus on range and standard deviation. Now range is very simple. See, in verbal, okay, we say range is from A to B. Okay, say from 10 to 80, right? For example, your exam scores are from 260 to 340, right? Or 265, sorry, 245 to 805. Okay, so the range simply means in verbal from A to B, right? Whereas in math, okay, in statistics, range means the highest value minus the lowest value. Okay, range means highest value of the data set minus the lowest value of data set. Okay, so if you look at the examples that we did before, 11 was the highest value, 1 was the lowest value, hence the range becomes 10. Okay, that does not mean that 10 has to be present in the data, it is simply highest value minus the lowest value. Okay, now interesting thing about range, okay, range always increases. Okay, whenever you mix multiple data sets, right, range always increases. Okay, it will never decrease. Okay, so if you have multiple data sets that you combine, you can combine them, that's not a problem, but the range always keeps on increasing. There's nothing you can add to your data set to decrease the range. Okay, whereas you can remove certain values obviously to decrease the range, but remember, if you are just merging two values or if you are adding a new value to the data set, then the range can only increase. It can stay the same, or increase, right? Increases or stay the same. Okay, now standard deviation, okay, is average deviation from the mean value. Okay, it is average deviation from mean value. Okay, so what does that mean? That, see, I'll have my data set. Okay, I'll have some 10 values of my data set. I will find the average of it. Say again, let's take the first example, 1 1 2 3 5 8 8 8 9 10. Okay, these are 10 values. Okay, if we find the average of it, right, that's 4 7 12 20 36 25 5.5. So the average of this data set is 5.5. Okay, so what I do, we look for deviation, that okay, 1 is minus 4.5 behind it, and this is also minus 4.5, 3.5, 2.5, minus 0.5, right, plus 2.5, 3 times 3.5 and 4. So this is on an average the deviation. That means, see, none of the values are equal to 5.5, right? They are deviating from it. Okay, and what is the deviation? These are the deviation. Okay, now what we are looking at is average of these deviations. Now a problem here, right? If you think about it, if you say that okay, average means you add all of them, divide by total. If I add all of them, the sum will become 0. Because that is what average is. Average is the common value, right? Whatever is above it, the same thing is below it. So if I add all of this, that's there's no point, right? Because this will become 0. So then how will I calculate my standard deviation, right? Another thing, right? So if you think about it, like, how to solve this problem, right? So see, end of the day, this is error, right? Now error, whether it be -1 or +1, it is error. Okay, or similarly, if you say deviation, right, whether you are one behind or one ahead, you are deviating by one value. So what we actually want is that this minus 4.5, this plus 4.5 are creating the same amount of deviation. So instead of taking this as minus and this as plus, I need to take both of them as plus. Now there are only two operations. Okay, I hope you understand that. Now there are only two operations in math that do that. We have studied those. One is absolute. Okay, one is absolute or modulus. We can't take modulus. Another is square. Right? Another is square. If you think about it, square of minus 4.5 is plus 20.25. Square of plus 4.5 is also plus 20.25. So what we do, instead of taking the values, the deviation values, we square them, so that now everything becomes positive. Okay, minus 4.5 plus 4.5 give me the same answer. Alright, so we square them, and now that they are all positive, now we take average of this. Okay, now we take average of this. Alright, so that becomes d square by n, right? Sum of all d square by n. Okay, so now average is done, but if you remember, we had squared it. So in order to bring it back to the form, what will we do now? Square root it, right? So this is how we calculate standard deviation. Okay, let's write this in a very simple manner. So that is, standard deviation is summation of all the deviation squares. Okay, average of that, square root. Okay, now with respect to our exam, calculation of standard deviation may or may not come usually. Whatever they do, as I said, this topic is a lot more theoretical, so the questions will come, like a lot more questions will come theoretical. Okay, but having said that, I hope you understand the calculation of deviation. Again, what is standard deviation? Standard deviation is simply average deviation from mean value. Okay, that on an average, how are the values deviated from the mean value? Okay, what is the error? Am I going too far? Am I going very close to the mean? Okay, what is it? Now if you think about any data, okay, what sort of data do you think is more accurate? One that has more standard deviation or one that has less standard deviation, right? So think about it. See, what do I want? Whenever I say, for example, I take a heartbeat machine, right? And if I try to take my heartbeat, okay, what do I want? I want the data to be as accurate as possible. I don't want it to give me 90 sometimes, 60 sometimes, right? I want it to give me 72 all the time, right? So the lower the standard deviation, okay, or the lesser the value, right? The lower or say lesser the value, the better the data. Okay, so when we talk about standard deviation, what we are looking for is the lesser the standard deviation, the better it is, because what does that tell you? That all the values are very close to each other, so accuracy is very high. Okay, all the values are very close to each other, so accuracy is very high. So what we prefer in any data is the standard deviation to be as low as possible. Okay, now let's quickly recall. Okay, let's quickly recall whatever we have studied till now, and then we'll see some magic. Okay, so we have studied, see, there are two ways to represent data, or two things required to represent a data. One is your central value, which is mean, median, mode. Okay, and then you have a dispersion value, which talks about the error. So you have range, you have standard deviation. Okay, we have range and standard deviation. Okay, we want the standard deviation to be as low as possible. Now, okay, let's take an example. So say we have 5 values. Okay, say we have 5 values, 1 2 3 4 5. If I look here, the mean is 3, median is again 3, range is 4, 5 minus 1, right? And standard deviation is root 2. Those of you who are interested in standard deviation, you can actually solve it and find. Okay, standard deviation should come as root 2. Okay, so these are the values that I already have in my data set. Okay, now let's learn what happens, okay, if I change, okay, if I make changes to the values. Okay, what will happen, okay, if I change all the values, okay, what will happen to my mean, median, range and standard deviation. Okay, so if you want, we can make a table. Okay, so we have changes we make to each value of data set. Okay, and we have corresponding, okay, changes in central value and dispersion values. Okay, so say this is your table. Okay guys, understand this will help you tremendously. Okay, this is super important. Take your time and understand this will help you a lot. So what we are doing is, we have a sample data set 1 2 3 4 5. What we are going to do now is, we are going to make certain changes to all the values. Okay, to each of these values we will make a certain change, and we'll see, or we'll try to observe what are the corresponding changes in my central values. What are my central values? These are my mean, median and mode. Okay, mean, median and mode. Okay, and what are my dispersion values? This is range and standard deviation. Okay, so say, right, say to begin with, I add 10 to each value. Okay, I add 10 to each value. Okay, so step 1, right, what I am doing, I am adding 10 to each value. Okay, so if I add 10, what happens? The values become 10, 12, 13, 14, 15. Right, 10, 12, 13, 14, 15. Now if you look at the corresponding changes in mean, what will happen? If you see, mean has become 13, median is also 13, the middle value. Range, if you see, previously was 5 minus 1, 4, now it is 15 minus 11, again 4. Standard deviation will again be root 2. Okay, standard deviation will again be root 2. Okay, so what do we understand from here? That if you add or subtract a certain value to each value of the data set, okay, then the central values add or subtract by the same, which is logical also. See, think about it. What is central value? A single value that represents the entire data set. Okay, now if you change the entire data set by 10, what will happen? The central value also has to increase by 10, because it represents the data set, so it has to express that, see, the entire data set has changed by 10, so I am also changing by that 10, right? So the central values, because they represent your entire data set, whatever changes you make, right, they have to represent those changes, so they will change by the same. But the dispersion, right, range and standard deviation, they do not change at all. Okay, because the gap has remained the same, right, nothing has changed there, so they do not change at all. Similarly, right, similarly, say we multiply, okay, say step, we multiply each value by 10. Okay, so now my data sets become 10, 20, 30, 40, 50. Okay, I have multiplied each value by 10. So what are the corresponding change? So mean has now become 30, median, middle term, again 30, range 50 minus 10, 40, standard deviation will become 10 root 2. Okay, so the point is that if you multiply or divide each value by k, then because they represent the data, they have to change by the same, but here deviation, okay, sorry, dispersion, the range, standard deviation, they also get multiplied or divided by k. So which then tells you that, see, a good way to reduce standard deviation could be that you multiply, right, divide the data by a certain value. Okay, if you divide the value by more than 1, the values will come closer. The closer they are, the lesser the standard deviation. Okay, so understand this table, understand how changes that we make to each value of data set, how they affect, okay, how they affect your central values and dispersion values. All right, if you understand this, okay, if you understand that, right, then let's see what will happen if I add a single value to my data set. See, what we learned just now was what happens if I change all the values of my data set, okay, by a certain value, right? Now what we are doing is, right, we are going to add a new value to the data set, and we will see what are the corresponding changes because of that. Okay, so say, right, say for example we have a student who has written multiple mock tests. Okay, say we have a student who has written multiple mock tests. Okay, because of these mock tests, like in these multiple mock tests, say the average score of the student is 80. Okay, say the average score of the student is 80. We calculate the standard deviation. The deviation of the student, say, is, say, right, say 8 marks. Okay, the deviation, standard deviation of the student of those, say the student has taken 100 tests. Okay, so mean is 80, standard deviation is 8. All right, now the student is going to take a new test. Okay, now the student is going to take a new test. Okay, and we need to figure what will be the corresponding changes, okay, because of this new value to my mean and standard deviation. Okay, so say the student writes the next test, scores really well. Okay, say scores 97. Okay, say the student takes the next test and scores 97. Now if you just think, right, if you think what will, right, what will this do to the student score, right, what will happen to the mean? The mean will increase, right? If you think about it, the mean will increase because my new value is much larger. Okay, it's more than 80. So every time I score more than 80, my average, my mean increases. This all of us understand, right? So now think, what will this 97 do to the standard deviation? Okay, what will this 97 do to standard deviation? Now, what is standard deviation? Again, it is an average value, but average of what? The deviation, right? Deviation from what? The mean value. If you look at 97, okay, if you look at 97, what is the deviation it has? 17. Okay, the deviation of 97 from the mean is 17. Okay, so it's very far away from the mean. Okay, further than your average of 8. So now think, what does 17 do to 8? Okay, what will 17 do to 8? The same thing 97 did to 80. When my average was 80 and I scored 97, the average increased. Right now the average is 8, new value is 17. What will this 17 do to 8? The standard deviation will also increase. Okay, the standard deviation will also increase. Why? Because this value is 17 points away from it. I am, on an average, we allow 8 points. So what will 17 do to 8? Increase it. So if you add 97 to the data set, mean will increase, standard deviation will increase. Okay, if you understand this, now forget this 97. Okay, forget the 97. Say the student scores 88. Okay, forget the 97 now. 100 tests, 80 is the average. Okay, 8 is the standard deviation. Now think, what if the student scores 88 in the next test? Okay, what happens to the mean? Increases, right? What happens to standard deviation? 8 points are allowed. Okay, on an average, the deviation is of 8. 88 brings with it a deviation of 8. What will 8 do to 8? Nothing. So there will be 0. That is no change. Okay, there will be no change. Now this is not exact, but it's good enough. Okay, it's a good enough approximation with respect to our exam. Okay, again, forget the 88. Say the student scores 85 in the next exam. Okay, forget the 88 now. Say the student had scored 85 in the next exam. What does this 85 do to 80? Correct, increases the mean. What does the 85 do to 8? Okay, so again my 85 is only 5 points away. Okay, it's only 5 points away from the mean. On an average, 8 points is allowed. So what will I say? This is closer to the mean. Okay, because on an average 8 point is allowed. 85 is closer to the mean. What will 5 do to 8 with respect to average? Say your average is 8 and now you score 5. What happens? Your average goes down. So similarly, your standard deviation will go down. So even though mean has increased, standard deviation will go down. Okay. Alright. What if the student had scored 80? Okay. What if the student had scored 80? Average was 80, scores 80. What happens? There is 0. No change. The mean remains the same. Okay. 80. Now, take your time. Right? Think what will happen to standard deviation. This 80 has 0 deviation, right? 80 has 0 deviation. So what will 0 do to 8? Bring it down, right? So your standard deviation will decrease because the new value that you are adding has 0 deviation. What will 0 do to your previous average? Bring it down, right? So the standard deviation decreases. Let's continue. Say the student had scored 74. Okay, the student had scored 74. Okay, probably not a good test, right? Scored 74. What happens to the mean? The mean now decreases. Okay, now think what will happen to standard deviation. Again, this is 6 points away. Standard deviation will decrease. Even though value is less, but it is still closer to the mean. Okay, and we know for standard deviation, above the mean or below the mean doesn't really matter, right? Error is error or deviation is deviation. Okay, so right. Next, say it is 72, right? Again, the mean decreases. 72 is 8 points away. What will 8 do to 8? Nothing. So standard deviation will not change. Okay, and finally, say the student scores 65. Very poor test. Okay, mean decreases. Now, think what will happen to standard deviation. 15. Okay, don't think of it as minus 15. For deviation, plus minus is same. So deviation is 15. What will 15 do to 8? Standard deviation will increase. Okay, so take your time. Okay, this is super important. Understand. Okay, what is happening? If I add a new value, we can understand or we can see what is the change that is happening to the mean and to the standard deviation. Alright, so if you have understood the concepts, let's jump into the questions. Right. So it says average of 5 scores is 84. Average of first 3 is 100. We need to find average of the last 2 scores. Okay, average of 5 scores is 84. First 3 is 100. We have to find the average of last 2. Okay, so again simple. 5 scores, average is 84. So total is 420. Okay, first 3 scores, average is 100. So total is 300. So if I subtract, I get 120 is the total of last 2 scores. Right? So average of last 2 scores is 120 by 2, 60. Okay. If you want, You can solve it using weighted average as well. So we will write first 3 scores, average is 100. In that, we add the last 2 scores with average x whole divided by 5 because total 5 scores. Overall average is 84. So again you get the same equation, 300 plus 2x is 420, x is 60. Moving on to the next one. So see, we have range of 6 numbers is 14. Alright, remember what was range? Highest minus lowest. What is the difference between greatest value of y and least value of y? Okay, so let's assume 2 scenarios. Okay, y is greatest. Okay, if y is greatest, I'll write the data as 5, 6, 9, 12, 18 and y. Okay, y is the greatest. Now what do I know? The range is 14. Range is highest minus lowest as 14. So the greatest possible value of y is 19. Similarly, we take y as least. So if y is least, okay, again range highest minus lowest is 14. We solve, we get y as 4. Okay, the question doesn't end here. We want the difference between the two. So 19 minus 4, 15 is the answer. Alright, moving to the next one. So we have a list of numbers and we know range is 7. Okay, again what is range? Highest minus lowest. We need to know the value of y. Okay, now if you have done algebra, okay, don't just rush and assume okay y is 1, 2, 3, 4. No. Okay, if you have done algebra, you will know that if y is between 0 and 1, then y square is less than y. Only if y is greater than 1, then y square is greater than y. Okay, so if we know y is positive, but if say y is a fraction, okay, say y is a fraction, then y will become the greatest value. Okay, then y won't become the greatest value, but y will become greater than y square. Okay, in this scenario, what will happen? Y square will become the least, then y, then 2, and highest will be root 5. But then the range cannot be 7 because root 5 is 2.3. Y square is some fraction. The range cannot be, okay, the range cannot be 7. So this scenario is not acceptable, which means we know y is greater than 1. Okay, this is how you solve. Okay, and now we know that okay, y is greater than 1. So the data will be arranged as 2 root 5 y square. Y can come before root 5 also or before 2 also, right? And then now we have y square minus 2 is equal to 7. Highest minus lowest is 7. Y square is 9. Mod y is 3. Do not rush and say y is 3. Okay, remember we have done absolute values. Square root of variables is modulus. Okay, so y, modulus of y is 3. Plus minus y is 3, y is plus minus 3, and you know y is positive, cannot be negative, so y is 3. Okay. An interesting question. Right, this says library is recording the number of visitors in Jan and Feb. The range in Jan is 15, range in Feb is 18. What is the smallest range? Okay, in both combined. Okay, so if you remember, I told you this before. Okay, if you want, we'll study this in detail now. Okay, the concept is range can only be increased, right? When you mix data, range either stays the same or increases, right? So if you have two data sets with range 15 and 18, the smallest possible range is 18. Why? Because the range can only increase. 18 cannot shrink to 15, but 15 can increase to 18, right? Okay, let's understand this, say with some numbers. So what can happen? See, the range of January is 15. So say the lowest is 5, highest is 20, the range remains 15. For say Feb, right, say lowest is 2, highest is 20. Okay, the point being that, see, if the range, okay, of Feb is 18, okay, this is say number line, range of Feb, lowest value of Feb, highest value of Feb. Okay, so this is 18, this difference is 18. Now if you look at January, the range of January is 15. So what can happen? January can lie here, right? This is the lowest value, highest value, in which case the range will become huge. January can lie here, these are 15 units, these are also 15 units. Lowest value is here, highest value is more than the lowest value of Feb. Then also the range increases, or January can lie in between these values, okay, in which case the range remains 18 itself, and the other way around, January can be here, right, or completely more than this. In all of these cases the range only increases, right, because initially the highest value of Feb was very high, whereas the lowest value of Jan was very low, so the range was higher, right? So the only way the range can remain same is all the values of January fall within the Feb values. Okay, so range can only remain the same or increase. Alright, another interesting question. See, we have 5 warehouses with average of 10, median of 9. Okay, none of them are empty. That means somebody has to be working at each warehouse. Maximum number of workers in largest warehouse. Okay, so we have the concept of average also, we have concept of median as well. Okay, let's look into it. So we have, say, because we have random numbers, right, all the 5 warehouses may have different values. So I say let the number of people in, okay, let the number of people in the 5 warehouses be A, B, C, D, E. Now you know, for median we arrange the values. So say the values are in increasing order, which means E is the highest, A is the smallest. Now from the question I need to find the maximum value of E. Okay, from the question I need to find maximum value of E. From the question I also know that the median value is 9. That means the middle value is 9. The value of C is 9, because for 5 values median is the third term. So C is 9. Also average is 10. Okay, also average is 10. So 9. So A plus B plus 9 plus D plus E, which needs to be maximized by 5, is 10. A plus B plus 9 plus D plus E max is 50. Now if you think that sum of, see, say there are 50 chocolates and there are 5 of us, okay, and we need to divide the chocolate so that I get the maximum. So what will I do, right? I'm the elder in my house any which way, so I do tend to get maximum chocolates. But what do I do, right? You know, I take the most and give the least to the others, right? If I want E to be maximized, okay, then all the others need to be minimized. Okay, we need to give the least to all. So what will happen? Because it can't be empty. I'll send one person to warehouse A. The question doesn't say they are different values, right? No. So I will send one person to warehouse B. Warehouse C is already 9. D will be 9, cannot be 1. Remember, in the beginning only we decided that this is ascending order. So D cannot be less than 9. Right? And then Emax is 50. So if you solve this, maximum value for E is 30. This is an interesting question. So we have the number of laptops sold for 6 of the 7 days. The values are given for 6 of the 7 days. The 7th day, the value is either 3, 5 or 6. Now, for which of the value is the average equal to the median? Okay. So, for which of these 3 values is the average equal to median? Right. Okay. Now, if you're interested in just solving the question, the simple thing or the simplest thing to do is just take one time, like one value as 3, solve for it, get the answer, and see whether average is equal to median or not. 5 average is equal to median or not. 6 average is equal to median or not. Okay. For example, right, if we solve that, right, say the 7th value, right, 7th value is 3. So your data set will become 3, 3, 4, 5, 8, 9. Okay, your data set will become 3, 3, 4, 5, 7, 8, 9. Okay, so these are the 7 values. The median will be 5, right? Median will be 5. If you look at the average will be 39 by 7, right? And you know median and average are not the same. Okay, similarly, now if you take 7th value as 5, again if you look at the median, so the values are 3, 4, 5, 5, 7, 8, 9. Median will still remain 5. Average will become 41 by 7. Again, not 5. If you take the 7th value as 6, right, the data becomes 3, 4, 5, 6, 7, 8, 9. Median is 6. Average is 42 by 7, which is 6. Median and average are equal. So 6 is the value. Okay. So this is one way of going about it. Okay. And there is nothing wrong in it. You can do that. Let's try to solve this theoretically to understand the concept. Right? To understand the concept. So what do we have? Right. See, if I arrange the data, I know the values are 3, 4, 5, 7, 8, 9. Okay, these are the 6 values. Now, the 7th value, okay, if you think about the 7th value, okay, the 7th value, because these are the 2 middle values as of now. These are the 2 middle values as of now. The 7th value will either be less than 5, okay, less than 5. Say this is the 7th value x. If it is less than 5, the median becomes 5. Okay, if it is less than 5, the median becomes 5. The value can be between 5 to 7. Okay, x can be less than 5, in which case the median becomes 5, or x can be 5 to 7, in which case x will come here and x itself will become the median, right? Or else the value can be greater than 7, in which case 7 becomes the median, right? In which case 7 becomes the median, right? So you basically have three cases. Okay, you basically get three cases. The new value is less than 5, between 5 to 7, or greater than 7. Okay, in these three cases, here the median becomes 5, here the median becomes x itself, and here the median becomes 7. Okay, and now we just solve. Now you can solve. If average is equal to median, the sum of these is 24 and 12, 36. 36 plus x by 7 is equal to 5. You get x is minus 1. Right? Now, see, interestingly, because what happened here was, we were given that there are only three values. Okay, had the question been for what values of x, okay, do we get average equal to median, then you know x can be minus 1. Similarly, if I take x in this range, I get 36 plus x by 7 is equal to x equal to 6, which is what happened here. And then 36 plus x by 7 is equal to 7. Right, I get x is equal to 13. Okay, so had the question been that for what values of x is the mean equal to median, we would have gotten these three values as our answer. Okay, I hope you understand this. Alright, and super easy question now. We have already studied this. So if you look, it says we have the mean, median and standard deviation. Okay, we have the mean, median and standard deviation. Okay, 10 is added to each figure. Which of the statistics will change? So we know that when you add a certain value to all the data sets, the central values, that is mean, median and mode, right, change by the same. Standard deviation and range, right, only change when you do multiplication or division, right? So since we are adding, mean and median will change, standard deviation there will be no change. Again, this is similar to the previous question type, right? What do we know? Okay, we have 5 values, T, S, R, Q, P, all are greater than 2. Okay, what are we supposed to do? Decrease the standard deviation. Now, what do we know? How can we decrease standard deviation of data set? So, standard deviation decreases if you divide each value by an integer, correct? If you divide each value by a value greater than 1, right? Or else you can multiply, right? You can multiply the value by a fraction, right? If you multiply by 0.5, 0.6, then also the value shrinks. Or you divide everything by 1.2, 1.52, 410, again the value shrinks, right? Since we already know this, now we just see which option helps us do that. So if I multiply by t by s, t by s is greater than 1. Multiplying by greater than 1 will increase the standard deviation. Divide by q by r. Q is less than r. So you are dividing by a decimal value. So what will happen? Again, the value will inflate. Multiply by minus 1, standard deviation, no change, right? Divide each term by s by t. Again, s is less than t, right? Again, s is less than t. So you are dividing by a decimal. So again, standard deviation will increase. Multiply by r by t. Yes, because r is less than t, right? So you are multiplying by less than 1. If you are multiplying by less than 1, the values will shrink, standard deviation will decrease. another theoretical question. So again, what do we know? Standard deviation is the closer the values are to each other, the lower the standard deviation. The further away they are from each other, the greater the standard deviation. So if you look here in data 1, they are all in AP, but the difference is of 5 each term. Here the difference is 2. Here the difference is 1. Remember, positive negative does not really matter. Okay. So since the values are closer here, we want least to greatest. Data set 3 will have the lowest, 2 and 1 followed by 2 and 1. So lowest or least to greatest will be 3 to 1. Now again, if you remember the table, that will help you solve the question orally. See, what do we have? The mean is 45, right? The mean is 45. Standard deviation is 6. Okay, what are we supposed to do? We have to decrease the standard deviation, right? The most. So we have to decrease the standard deviation a lot. So what do? We add a value, okay, which is as close to 45 as possible, because that will then decrease your standard deviation a lot, right? So if you look at the options, the values closest to 45 are 44 and 46, right? So what will 44 and 46 do? They will introduce a deviation of 1. What will 1 do to 6? Decrease it a lot, right? So 44 and 46. So alright guys, I hope you were able to understand the concept clearly. Okay, you understand the theory behind it, and you realize that, see, most of the questions are theoretical. So if you understand the logic, you can solve most of these questions, in under a minute, minute and a half. Okay, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and try to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.